Hello, hello everyone. This is my submission for the take-home assignment for the Skillo intern project, and here we go. In this project, I was given a problem to make a pipeline which would feed on the audio files from the CRM integration or the file-based. For this project, I have implemented the file-based ingestion. For the production, I would also implement the CRM. As we would move through the project, you will see that I have made the project source agnostic and vendor agnostic for both LLM and audio ingestion. So let us start with the backend. So here, this is my project structure for the backend. I've made the backend in Fast API, and I've tried to keep the code modularized, although for the timeline which I have been allotted, um, I've done my best as possible. So let's start with the audio ingestion part. I have taken two sample audios which I have made subfolders according to the IDs of the advisor, so that there would be idempotency check in the backend. So let's start with the core pipeline first. Here I have made an adapter class for both the analysis service and the integration with the CRM. These both classes will help to keep the code agnostic. If we change our provider for LLM, we just have to create a new class and define this method for that implementation. And same goes with the CRM integration. In data services, I've created a file-based retrieval which retrieves the audio from the folder and checks them for the ID, and also provides the audio bytes for every audio. In LLM services, I have also created the Gemini service for now, using that same analysis services class, and defined the analyze call service. If we change our vendor, we just have to create a new class using the same analysis service, inherit from it, and define just one method for it, and nothing would be changed in the main file. To keep the output verified, and to prevent any errors from the LLM, I have created some schemas to ensure that the output is always what we expect. So for the output, I've used a call analysis and used pydantic based model and field structure to provide strict typing. This is a call analysis model. uh, it first it checks, is this a sales call. It contains a list of dimensions, and dimensions are some enums, like we providing tags for the calls, like what happened in the call, and providing a score on base of that, and one line justification. And for the tags are for creating issues. If the call has some issues, the tags will be created by LLM, and they are also scored, they are also quoted, and the timestamp is also given for the, and also a reason. And these both models are used in call analysis model to provide the structure output. This structure output here is used in the structure output from the LLM, and here also it is validated before returning to the next service. So this was the schema. Here I've used the transcriber. This is my transcribe class, which uses a Deepgram API. A Deepgram API provide a very versatile service, including the redaction, diarization, and transcription. So the all audio needs were fulfilled by Deepgram. So I strongly encourage to use Deepgram for production also. And here what I have done is that first send my transcription file, send my file to the Deepgram client. Here you have seen that the transcribe file expects the audio bytes, and we will see in the main pipeline file that everything is agnostic. After getting the response, we create the segments, like which is for the diarization and tracking timestamps also. Here we are doing diarize only. If yeah, This was our transcription class. Now let's move. I've created one small helper method which is to verify tags. As we know that our LLM output also producing tags for the issue. Here what it does, if it will check all the tags whether the tags produced by the LLM are not on some made up codes, like the code has to be from the call transcription, not created by the LLM. So this method verifies this functionality, and it uses a small class from the difflib, which is sequence matcher. It uses fuzzy logic to matches strings and gives the output of matching. So now moving on to the main orchestration file. Here I have created the main method process call, and this method run ingestion batch uses the above method to run the processing pipeline per call retrieved from. So here you've seen that I've created a file based retriever, here the transcriber, and this is the Gemini service which uses the same API key, which uses the same analysis service class from the adapter. So what process call does is that it receives all the services, the transcriber, the analyzer, and the call record for which we are processing it. First we are making an idempotency check, like whether the call has been already processed or not, or so if the call has been processed, it will return the existing processed call. Also, we will also check for the orphaned calls, like if a call does not have an advisor or the advisor data is not available, it will raise a value error and will continue further. So we create a dummy call and start its processing. We update the call status early so that it can be surfaced on the dashboard early, and director can check whether a call is under process or not. Here we do the processing of the call. We first start with the transcribing. So the fetch audio method, like I've explained in the file based retriever, if we use another class like a CRM hook or something, we just change the service from this file based retriever and the method will be the same. So nothing would have to be changed here, and the fetch audio implementation would take care of retrieving the audio bytes for the further processing. So the audio bytes are received by the transcriber, and the format segments is a small helper method which just takes the timestamp and the line from the segments. So after this formatting, the formatted transcription is provided to the analyzer, which is the Gemini service analyzer. Also, you can see that if I change the provider to OpenAI, maybe I just have to implement the new class and initialize it here with the API key, and nothing would have to be changed here because the abstract methods are really helping us here to keep the code agnostic. So the implementation here will help us to not to make any changes. This is the verify tags method, which the small helper method verifies the tags. So after verifying, if the LLM analysis came to be that it is not a sales call, we just update it accordingly and create the results for the database. And after that, all the data is updated on the database and committed. Also, I have taken care of any of the error processing here. Because we are making too many database operation, everything goes in a commit. So if anything fails here, we simply roll back and provide another status and update the database accordingly. So this was the main pipeline core, the main pipeline that does the operation of ingesting, transcribing, and analysis and providing the data. It uses all other helper files. Now I will show the database model for the application that I've used. This is the small file that initializes the database using this URL. I've used a localized Postgres instance on the Docker. It makes the development very straightforward and easy. I also encourage you to test it with the Dockerized Postgres instance. So moving further, here I have initialized the database and provided a database session wherever the code uses it. In my models folder, there are two files, API models and database models. Database models contain the models that are used by the database operation and the database itself. First model is organization, to provide the organization facility. Organization will contain teams. So there is a relationship which is a one-to-many relationship to teams and users. So this is the teams. Teams will have users, and so a team will have a one-to-many relationship to the users and advisors, because a team can have advisors also. To make it clear, advisor is just a person who is making a call, and it is specified in the user profile, like if a user is a advisor or not. It is specified by the role, which take care of the role of director and a team leader. So this user model helps us to provide a role-based access to the dashboard and surfacing user-facing applications. The advisor is just a relation to the user, which specifies which is the user ID and team ID. This is a call model which represents a call, like it will contain the external call ID, which will be from the CRM or created in the file based. Source is the like specifying what is the source of the call, name of the CRM, telephony or file based. Audio URL, it can be a file path or the audio URL provided by the third party CRM. And status, which tells the status of the calls. Failure reason, if the call analysis somehow fails, it tells the failure reason. And rest are the metadata and the relationships to the other models. The relationships to other models for the call is result, scores and tags. Result is the transcription result of the call, like transcript and the diarized, and it has a relationship to the call. The scores model has the dimensions, each dimension and its score. So this is a one-to-many relationship between call and the score, and the same relationship between the tag and the call. So the tag represents the issue. Here we are taking the tag type, its severity, code, timestamp and the reason. So this was the data models, and these are my API models. They are made with Python tech, so that everything can be ensured and there are no unexpected errors. So these were the data models that I've used. Now let's move forward to the orchestration of all this into a web server, which is made into the Fast API. Here I have made the server in Fast API. I have taken care of the course because I've created the client application with React plus Vite, which is running in a separate shell. So I have stitched everything here: the sign up, the login, the user session, and these are all the data surfacing routes which are used in the dashboard. This code could have been more modularized, but for the sake of completion, I have created it right now. So now let's move forward to the front end. For front end, I've created the front end in TypeScript, React, and Vite. I've tried to keep the development of front end as minimal as possible, but it's minimal in design, not in the functionality. Starting with the API, here I've created an interface for the API so that the code could be more modularized. And here I've defined the types for all the request objects or response objects that will be used throughout the application. So this is the API client and this is the function. Here I have defined the request function to be generic, so that path and both options can be dynamic, and it's just uh, produce, and it just makes a request and gets the response and is used accordingly. The way it is generic, it won't cause any type errors wherever it is used. As it's an auth, I have also created a common interface for the auth because we have three stages of the auth. First is sign up, login, and token retrieval. So the login here will create the API post request and is used accordingly. The for the auth and authorization, I have used the JSON web token. Let me show you the implementation in the backend. It is in the utils. I apologize, I have not covered that earlier. So this is the utils. I have used hash password and verify password from the bcrypt library to store the passwords in a very secure manner. These two functions keep the database seedless so that we don't have to create anything in the database manually, because if there is an organization that does not exist, it is created automatically, and same goes with the teams. I would encourage to remove these functions in the production because no, we do not need to create organization for every new for a typo, for example. And this is the token creator and decode token. These two methods are used throughout the application to verify the JWT sent by the client. So again, keeping up with the front end, a common interface for auth that covers the authentication of login, sign up, and token retrieval. Components use some badges and layout. The badge here, we use it for the front end functionality. Uh, there's not much in the components. These are the visible items, and it is for the navigation bar. Here I have also taken care of the role formatting. Like in the database, we are storing the enums. These would not look good in the front end, so this is a very small function for role formatting. So moving on to the pages. Actually, instead of going through every front end code, uh, let me show you the front end in action. It's running currently. This is my Excalidraw. I'll share the link in the readme.md. You can view it easily. And here it is. I have already processed the calls. I only had 2 audio files, and that is why it is showing 2 here, only 2 audio files. This is the overall quality score. There is a 1 flagged calls and there are no currently disputes. This is the team that I have created for now. If you go to the calls, these are the scored calls that were created. Here you can see you can have complete transcription, overall scores according to the rubrics, flags if there are any raised flags, with the timestamp and the exact transcription. I will provide the sample audio file in the my deliverables and my submissions, so you can test the code with yourself. Here the call has been scored. In this call there were no flags. The rubrics were scored accordingly with timestamp and the entire transcription. So this was my code, and I will honestly submit that I made this project with the help of Claude. But I did not use the Claude entirely just for copy pasting. We were taking many architectural decisions. Because if I show you like from the starting, See, we have been making gaps. We have been identifying gaps. Like I've been identifying gaps in the Claude code generated by the Claude. I've been giving my suggestions too, like what to do for the next. For example, this analysis adapter class, like we have created. This was not the option in the first iteration of the code, and that gap was identified by me. We then created the code source vendor agnostic for this one. uh, I have one more thing to show you, that although I've been using Claude for the uh, implementation, I have been using my own MCP server, which helped me to give the access of my code base to the Claude. So like if I type something here and ask it to inspect it, the Claude will have the access to my code base here without any issue, because I've made the tools for that. So that's how I was able to um, develop this project. And once again, I apologize for the late submission. I have been busy in some personal work, and my commitment was required there. I request you to please at least check the submission and run it by yourself, even though you might not decide to move forward with the application. So, thank you and have a nice day.